In this video we show how to perform multiple regression in ILLMO. The data file is the same as the one used by any field. It's actually an extension of the data file that we used to illustrate simple regression. The first two columns are therefore the same, so it's the independent variable adverts and the dependent variable sales. The difference is that we now have added two other independent variables called airplay and attract. So we can read this CSV file, indicate that sales is the dependent variable and the other ones are independent variables. And the data is interpreted as continuous. So again, we load one dependent variable, which is now predicted by a 3D pattern, which consists of the three independent variables, meaning attract, airplay, and adverts. So this pattern, 3D pattern, is used to make a linear prediction for the dependent variable. Linear prediction means that there are three coefficients which are used as multipliers, which are called the main effects 1, 2, and 3. And an offset is added, and these values determine the prediction. So if you want a more coherent picture, so the 3D pattern is used to make linear predictions, which are then used as the averages to create distributions, and they are compared to the incoming histograms, which are again stepwise functions, as there's only one observation for each case. In ILLMO, the way to check whether each of these factors has an influence is to check the log likelihood profile, for instance, for each of these coefficients, which means, for instance, that the first coefficient is significantly different from 0. We can also request the log likelihood profiles and the confidence intervals for all three in a row, so we coefficient 1, coefficient 2, coefficient 3. So they're all different, significantly different from 0. We could also have a look at the offset and find also the confidence interval for this offset. Now, of course, we could also perform more traditional statistics, which are also included. So we have a multiple regression, which would provide kind of scatter plots and a lot of other information, also textual information, one of them being the estimates of the coefficient, the estimates of the confidence intervals, and the ANOVA table, which amongst others shows that the correlation coefficient is 0.815, with this confidence interval is indicated here. A somewhat more cryptic piece of information is the partial correlations. For instance, the first one actually expresses how much variance can be explained by just this single variable, at least that cannot be explained by the two other variables. There's another interesting extension that ILLMO offers to traditional regression. It's called multimodal regression. So if we apply that, what this option actually accomplishes is that it not only performs a regression with all three variables, but it performs a regression with one variable dropped and with two variables dropped. So in total we have 7 models which are successively compared using multimodal comparison. So in this case, almost all of the weight goes to the model with 3 predictors, again showing that all 3 predictors are actually valuable to make a prediction. This multimodal comparison is also offered as a table to be manipulated separately. Now let's go back a little bit to the partial correlations that we had before and see how this idea of partial correlations can be extended and made more insightful in ILLMO. The first partial correlation actually says that how much does this first predictor, x1, actually predict that the aspects that cannot be predicted by the other two. So in which sense is this predictor complementary? Now the lowest one is the one for partial correlation for the third predictor. It's about 0.3. So let's see if we can actually create that value in a different way. So if you first try to see what part of the independent variable can be predicted by the first two, we created now a 2D pattern, and we export the result. Well, not so much the data itself, but the residue values. So that creates a second attribute, which we can now correlate with the first, sorry, with the third, the one that we haven't used. And if we now perform a simple regression of this single independent variable against the residue from prediction by the other two variables, we get a correlation coefficient of 0.3, which is similar to the partial correlation that we've obtained before.